Hello everyone, thank you all for your time and attention. I'm sorry if I'm a bit informal because I suddenly found an error on my recent project and I decided to fix it. So today I will present my work for my network final exam. So first of all, let me introduce myself. My name is Arlen Sasenka and my student ID is 2315101057. Okay, so today I will explain about the design, addressing, subnetting, and routing configuration for our organizational network using Cisco Packet. So the first one I will explain about the organization's network consists of 4 facilities, each with specific networks and host requirements. The first one is the central facilities. So the central facilities can be accessed by the other facilities. For the first one is the central facility require 400 hosts. The first facility requires 255 hosts. The second facility requires 100 hosts, and the third facility required 150 hosts. So the address range given for the entire network is 172.16 and 00 with /21. The goal is to ensure efficient use of IP address while reserving enough for future expansion. So all devices must be interconnected to each other. To demonstrate connectivity, I will use a packet sent from PC0 in the central facility to PC5 in facility 2, but I will show it in the end of the video. So after this, I want to explain first about subnetting. So to meet the host requirements, we calculated the subnets using the given range. So the biggest facility, it is the central facility for router 0 with 400 hosts. The host minimum is 512 IP with the subnet mask /23 with for the subnetting, maybe I only explain the host minimum because all the details I will be put it on the report file. So for the facility for the router 1, 256 IP. Sorry, for the router 2 in facility 1, 256 IP. In facility 2, 128 IP, and lastly on facility 3 with router 4, 256 IP. Okay, so next explaining. Okay, so the central facility, the facility 1, facility 2, facility 3. I already explained. Facility 1, I use /24 because it will provide 254 usable addresses. Facility 2, I use /25 because it provides 126 addresses. And facility 3, same like facility 1, I use /24 because it will provide 254 usable addresses. So with the setup, we ensure that efficient allocation while reserving space for future use. Okay, so next I will explain about the topology design. The network topology includes the following components, which is the PC for end devices, central router for every facilities, and then switches and servers, switches for connected device to each other, and then servers to maintain the IP addresses with the HCP concept. So each facility has its own server connected to the switch to localize traffic and reduce latency. Because in my experience, when I use server only on the central facility, it will make it harder to configure it. So I think giving server to each switch make me easier to configure every router. And then the routing protocol. So in this topology, I use Eigrp, which is enhanced interior gateway routing protocol, because the first one, it is efficient handling large network. The second one, it is easy to configure rather than the Eigrp, and then the scalable for future network growth. And also it optimized for low bandwidth usage, which is beneficial, and also for serial connection between routers. Okay, so for configuration steps, the first one is device placement, of course, and then subnetting. I assign IP addresses to each subnet based on the calculation provided earlier that I explained, and also you can see it on my report. And then I configure the IP addresses on router interfaces and servers with static IPs. And then for the each end devices, I use DHCP, and then at the end I configure the routing with Eigrp. On each router, enable Eigrp using the router Eigrp, and then the ASN, and then type the network that are connected to every router. Okay, so in conclusion, this network design ensures efficient IP addresses for every device, seamless interconnectivity, and feature scalability. The use of Eigrp allows for fast and reliable routing across the network, making it the optimal choice for this organization. Additionally, placing servers in each facility improves performance by localizing traffic. So, thank you all for your attention, and thank you all for your time to watch my video.